This video lecture is about the Electron Cloud. At the end of this lecture, you should be able to describe and or answer questions about the organization of the Electron Cloud. We have a whole lecture devoted to the Electron Cloud because chemistry is really all about electrons and how they're arranged and how they behave inside of atoms. An interesting thing about the electron cloud is if you picture an atom, we've talked about this before in one of our other lessons, but there's a very, very small, extremely dense nucleus in the center of an atom, and then almost all of the space, all of the volume of an atom is taken up by this three-dimensional electron cloud. And it's almost entirely empty. The electrons that are zipping around very, very quickly inside of that cloud are very, very, very tiny. And where they're at inside of that three-dimensional area is very difficult to know. We didn't know very much about the electron cloud for a very long time. And when humans first started to develop quantum mechanics, quantum physics, they started to understand how very, very small particles, which the electron is, how very, very small particles worked. We started to understand how the electron cloud was organized a bit better inside of atoms. So basically what it comes down to is using a bunch of really interesting principles from quantum mechanics, and if you're interested in this kind of stuff, it's very deep, very fascinating, very high concept stuff, and there's a lot of information out there about it. But using calculations from quantum mechanics, chemists came up with equations to describe basically the shapes where electrons probably are around atoms. And these shapes they termed orbitals. And using these three-dimensional shapes, you can build up the electron cloud of any atom. So here's how this all works. There are basically three components to every orbital that's in an atom's electron cloud. So the first one is called the main energy level. Now, the main energy level, as far as we know, ranges from 1 to 7. If we discover some more elements eventually, it's possible that it could go up higher, but for every element we've discovered so far, it's 1 to 7. And it basically describes the overall amount of energy that's in the electrons in that orbital. The next kind of important characteristic of these three-dimensional spaces in the electron cloud, where electrons probably are, they're called sublevels. Sublevels. So on a main energy level, there will be one or possibly more sublevels. And then in the sublevels, we have these, well, the sublevel is basically like a three-dimensional shape where the electron probably is. And we're going to get into that a little bit more later. But so you've got the main energy level, which is approximately how much energy the electrons have in these orbitals. The sublevel is basically the shape that an orbital can be at that main energy level. And then the next one, we're just going to go ahead and call it orbital. There can be more than one orbital in a sublevel because some of the shapes can be oriented differently in 3 dimensions. So it's a little bit complicated, but it's not totally just completely out there. You can totally understand this. What they'll do is they'll assign numbers to these, and that makes it a little bit clearer. So the main energy level can be from 1 to 7. And the sublevels don't get numbers, but they get letters. So it's S, P, these are lowercase by the way, D, and F. Those are all the possible sublevels. And then the orbitals don't really, have any other kind of additional name to them, but the sublevels can each have a specific maximum number of orbitals. So the S sublevel can only have one orbital in it. The P sublevel can have 3 orbitals in it, and the D sublevel can have 5, and the F sublevel can have 7. So basically, I like to use an analogy for the electron cloud, and that is the analogy of like an apartment building. If you think of an apartment building, here's an apartment building. The floors of the apartment building are kind of like the energy levels. So that's one way to divide up our apartment building. And then the main energy levels can have one or more of these sublevels. So for instance, on the first main energy level, there's only one sublevel, and that sublevel is S. So that would be like there just being one apartment on the first floor. So that's the first floor, and there's only one apartment there. And then the sublevels have various numbers of orbitals inside of them. The S sublevel only has one orbital. So this one apartment only has one room. But on the second floor, there's two sublevels. There's S and P. So this is the S apartment. This is the P apartment. And this is like energy level 2. This was energy level 1 down here. This was an S apartment. And S apartments only have one room, so we don't need to divide that up anymore. But P apartments have 3 rooms. So it would be like the P apartment would have 1, 2, 3 rooms inside of it. And those would be where the orbitals are. And this is kind of how it gets subdivided up. Now, just to make it a little bit easier, let's color code that. We'll make main energy levels red, and we'll make the sublevels green, and we'll make the orbitals blue. So in the first main energy level, that's the first main energy level, there's one sublevel, which is sublevel S. Sublevel S. And inside of sublevel S, there's only one S orbital. So there's just one room inside there. But on the second main energy level, there are 2 sublevels, the S sublevel and the P sublevel, are 2 of those. And then in the S sublevel, there's only one orbital. And in the P sublevel, there's 3. 1, 2, 3. And that's kind of how the electron cloud is organized. Now, there's a pattern here. This is the first energy level. This is the second main energy level. This is the third main energy level. You'll notice the first main energy level had 1 sublevel, and the second main energy level had 2 sublevels. Can you guess how many sublevels there are on the third main energy level? If you guessed that there were 3, you would be correct. There's an S sublevel. There's a P sublevel on the third main energy level of the electron cloud. And then there's a D sublevel. Now, where are the electrons? Where are the electrons in all of this? Well, the electrons live in the orbitals, and each orbital can hold 2 electrons. So each orbital can hold 2, which means that the S sublevel has 1 orbital, so there's 2 electrons there at the S sublevel. The P sublevel has 3 orbitals. Each orbital can hold 2 electrons. So 3 times 2 is 6. So in a P sublevel, there can be 6 electrons. And the D sublevel has 5 orbitals, so that means the D sublevel can hold 10 electrons. And the F sublevel has 7 orbitals, which means that it can hold 14 electrons total. So another way to think about this, other than using the building example, is to use a notation where you actually kind of draw out the sublevels, the main energy levels, the sublevels, and the orbitals. And I can actually show you this with an element example. So let's pick an element like, say, boron. Oops, got a little crazy there with my a little crazy with my B. Sorry about that. All right, so boron B. If you look on the periodic table, Boron's atomic number is 5, which means that it usually has 5 electrons. So boron has 5 electrons, and those electrons live inside of the electron cloud. So let's build up boron's electron cloud, starting with the first energy level. On the first energy level, there's only one orbital, and that's s. So we're going to say it's 1s. We're going to name this sublevel 1s. It's on the first main energy level, and it's the s orbital. And s has one orbital, and we're going to draw lines for those. So we're at main energy level 1. We're in sublevel 1s, and there's one orbital there. And every orbital can hold 2 electrons. So we're going to use arrows to represent the electrons. So here's one electron. We'll use it to point up. And just to distinguish them, we'll make the other one point down. So there's 2 electrons. So far, boron's electron cloud has one main energy level. And in that one main energy level, there's the 1s sublevel. And the 1s sublevel has one orbital, which is represented by this horizontal line, and that one orbital holds 2 electrons. But boron has 5 electrons, so we have to go up to the second main energy level. Hold on, I'm going to pause this and adjust just a second. I had to move the electrons and orbitals and sublevels down here, so it was easier to get it all on the page, on the screen at one time. So we've got 2 electrons in the single orbital of the 1s sublevel. That's in the first main energy level. Now we have to go to the second main energy level. And the second main energy level has 2 sublevels. So we're going to call those 2s and then 2p. And we know that the s sublevel has one orbital, so we're going to draw one line over top of it. Whereas the p sublevel has 3 orbitals, so we're going to draw 1, 2, 3 lines over that. And just to make sure we don't get confused, I'm going to draw a horizontal line between the 2 of those. Okay, so at the 1s, in the 1s sublevel, in the one orbital that's in that 1s sublevel, there's 2 electrons. And at the main energy level 2, in the 2s sublevel, in the single orbital in the 2s sublevel, there can be, again, 2 electrons. So that gets us up to 4 electrons. But that's still not enough, because boron has 5 electrons. So the next electron has to go into the second main energy level, into the 2p sublevel, into one of 2p's 3 orbitals. So I'm just going to go ahead and put it in the first one. And now we've got all 1, 2, 3, 4, 5 electrons that are in boron. So what that means is s sublevels are circular. So here's boron's nucleus. S sublevels are circular. So here's the first main energy level. That shape represents a sphere, which is the 1s sublevel, and inside of that there are 2 electrons zinging around. They're zipping all over the place. And then on the second main energy level, there's another sphere, and that's the 2s sublevel. That's the one orbital of that, and inside of that there are 2 electrons zipping around. But now we've got this 2p, and that's kind of like a dumbbell shape. So there's only one 2p orbital that's occupied, and they're kind of like dumbbells like this. They're kind of squished. I know it's weird, right? And somewhere in that dumbbell shape, there's 1 electron zipping around. See, 1, and that's what the electron cloud of a boron atom looks like if you could see it, which you can't really see it, but those are the 3-dimensional shapes where the electrons are probably at. And so all atoms' electron clouds work this way. And at this point, I think we're going to go ahead and stop this video. As always, you can ask me any questions in class if you'd like, but make sure you check out part 2 of this lecture, where I go through a few more examples of how you would write down an electron cloud and different ways, easier ways to do that. Thanks for watching.